Hello, everyone. I think it's time to start. I would like to welcome with a big applause Andrei from Enix, who will speak about treating Kubernetes as a Linux distro and some APT-like magic. So and how they solve the egg versus chicken problem. So handing over to you, Andrei.
Thank you. And it doesn't work. All right. So a few words about myself. I'm CEO and founder of Enix. We develop Cozystack. This is open source solution which allows you to automate data centers and solve various stuff around Kubernetes. You can know me from various communities, especially Cozystack, Linstore, KubeVirt, Talos Linux, Cilium, and so on. Talking about Cozystack, Cozystack is a platform which allows you to order managed services like you have in AWS, but it allows you to install it fully on self-hosted environment. The platform itself is fully based on Kubernetes, and we use open source operators and solutions from CNCF, Cozystack, also CNCF project. And today I'll be speaking about how we organized our packaging system in Cozystack. This is actually a dashboard where user can click and install any service they want to. But before we make this available, you need to prepare a stable base for your applications because all of them need, they have a need in storage, networking, virtualization, and also what does it mean, managed service? It doesn't mean that you just deploy a pod and forget about it. To make services truly managed, you need to ensure that all the day-to operations are working fine, like backups, monitoring, failover, and so on. For this, you need to have a stable base. Of course, we chosen Kubernetes. And before you start using Kubernetes, you can't use just pure Kubernetes. You also need a ton of components, such as storage, networking, virtualization, and monitoring. They are base for all the managed service we run in our platform. In fact, we just built such a platform stack, which includes operating system management, then specific components which solve storage, networking, virtualization. We also made them replaceable. Then set of operators, cluster API, monitoring system, and only on a final level, we provide user API to let them define their own applications and let their users to order managed services. The main core value of Cozystack is that we consist of many open source components and we just provide such a glue. We can make sure that all of these components working together well. So we continuously contribute to upstream projects. If we change anything, we rather go to upstream project and contribute there instead of implementing it in tree. And we make this stack reusable across various environments. It could be a cloud environment or your own bare metal environment. Bare metal also very different. So that kind of challengeable. Is that a distribution that looks like we solve the same thing like Linux distributions we're solving for 30 years already? Just use Kubernetes as a base. In fact, it is, and we organized our development quite the similar way. So we have monorepo pattern, where we include upstream charts, we slightly modify them. Sometimes we can also update the images, so we hold the patches in the same monorepo. In fact, we just take this monorepo and deliver all the components all together. Like new version of our platform is just single version of this single tag of this monorepo. Inside of this monorepo, we have few group of packages. First are system singletons. You can see such components like Cilium, Cert Manager, I know, ClickHouse operator, and things like so. So the components which get installed in a system at once. on a system level. Those apps are also Helm charts. They define user API to order the specific services. For example, user wants Postgres, Kafka. They have specific YAML to install specific instance in their namespace. We also have extra, it's slightly tricky tenant modules. It's tenant singleton charts, usually dependencies for make other components working. For example, if your user wants to deploy S3 bucket, they need to have a storage deployed in their tenant namespace. If they requesting Kubernetes cluster, they need a etcd running, which stores the data for this Kubernetes cluster. I usually tell charts are packages. In fact, Helm is a package manager, so why not? You can take a look at various distributions, Linux distributions and FreeBSD. They have quite similar organization of the packages. Especially I really like Alpine Linux because it has exactly the same structure we have chosen. But Gentoo, Nix, and FreeBSD, they have quite similar organization. For the distribution, we use FluxCD. FluxCD is a main core engine which delivers all the Helm charts in our platform. They could be system or user charts. In fact, the all is driven on by FluxCD, but we use it in different way. Originally, you take FluxCD and connect it to some external Git repository. In our case, we do that different way. We actually perform an artifact. And from this artifact, we deliver all the charts. This artifact contains actually all the charts, and we cut only this artifact. That means like specific platform version. For example, we have this Git with this structure, apps, extra system. We pack it into Docker image. Then we install it into specific Kubernetes cluster. And then Flux can install specific Helm releases from this OCI image. And also we have another level of abstraction, which represents the same FluxCD Helm releases as normal Kubernetes kinds with no reconciliation loop. So it's built on top of aggregation API. It just represents, instead of Helm chart, you see normal kind, bucket, kind, Kubernetes, kind, Postgres, and so on. But let's come back to the FluxCD. Where is this configuration stored? We have additional platform chart which holds all the configuration should be installed in a system. In fact, we have also core, platform core components, and this platform chart. It contains all the Helm releases. This is like Matryoshka, which contains many Helm release configurations. And we also have, so we run it, originally we were running it as a HTTP server in our platform and let FluxCD read the data from it, like charts data, and deploy into the same cluster. That was working fine. For the configuration options, because every customer needs different options to be installed, maybe some components, enable it or disable it, we introduced bundle system. For example, bundle 1 includes the first set of the components, bundle 2 includes the second set of the components. And they can also have different configuration because it's just up, pattern. Actually, you can choose the bundle, just provision the specific option for the platform chart. And then it will deliver the rest of the Helm charts into the platform. In fact, everything is a Helm chart, even this. That allows us to customize it very simple, and that drives us to the next part of the talk, is how to make the development convenient. The main trouble when you're developing stateful services, it's quite difficult to test them. Usual flow that you make some change in the code base, you push it to CI, you wait for building, you wait for end-to-end tests finish, then you see some error, and then you repeat it again. So we wanted to completely get rid of this situation, And we just invented Cozystack project and Cozy Flow developing flow. The idea is simple, that you can just take the source code of some Helm chart, you can simply rebuild it, somehow change, and directly apply to the cluster with the same values stored in the cluster. For this, we invented this Cozystack. It includes few options like show, diff, apply. Diff will actually show you what is changed between your live state and your local state in a repository. In Cozystack, we cover everything with a makefile, so every package includes the makefile. It also has a few additional targets like make update, which automatically downloads upstream chart. Yeah, we also render all the upstream charts in our repository in order to make some changes. For example, we can simply apply some patches or modify it somehow. Also, we have make image, which actually builds the local Docker file and records it into result values file. So in fact, we have this artifact which you can simply apply, and you can see how it's changed and test the behavior even before you push it into your CI system. The second topic is delivery. By making this platform distribution, we want to reach simple installation. We want to let our platform manage the state of whole Kubernetes, including CNI, kubeproxy, and so on. But the thing is, you can't simply install Cilium via Flux without Cilium and actually kubeproxy. That's actually chicken and egg problem. We were solving it different ways. The first option was to install Cilium manually, then hand over the management of this Cilium Helm chart to the FluxCD. That was working for some time. Actually, one small script of 100 lines of code was responsible for this. But we decided to solve this. It wasn't working very well. We wanted to have more native option to do that. And we just found Flux all-in-one project. It's Stefan's project. Stefan is a core maintainer of FluxCD. And probably for his home lab purposes, he built this option also because he wanted to install CNI before the Flux. So we started using it, but also during our existing system with internal HTTP server, it was quite challenging to solve that stuff. Because if you install FluxCD in a cluster, if you have this HTTP server running, but you have no kubeproxy and you have no CNI, you need somehow solve the case how Flux will actually connect to the, this HTTP server. There were some fancy options like to place them into the same node, but in this case, you need to jungling with these placement options. You can create a sidecar, but in this case, during updating the asset pods container, it will also restart the whole FluxCD. And we found more fancy solution. That's actually reusing Kubernetes API server in wrong configuration, I would say. If you know, Kube API allows you to run port forward, but also it exposes it as single HTTP endpoint. So if you're accessing Kubernetes API server under this path, like /port forward with correct certificate, which allows you to do that, you can actually download Helm charts directly from Kubernetes API because it will proxy to the pod which holding those Helm charts. That was a nice solution, but quite tricky. So we decided to go even more further to solve that complete and correct way. The correct way is to store this OCI artifact and don't run any HTTP server in our platform. But let FluxCD download the artifacts from the external Docker registry with no need to have HTTP server. Actually, the idea to pack everything into OCI image and just let Flux download it and install it with no need of HTTP server. But there is another problem, that Flux does not support OCI backed multi-chart Helm repositories. Even Helm does not support them fully. When Helm introduced their OCI support, they changed also behavior from the repositories to single packaged charts. So we can't just create a single image with some version, which is single artifact and single point of truth for our platform. To migrate this new scheme, we would need to pack any chart for any component into specific artifact. And these are actually multiple artifacts and no single point of truth. We didn't want to do this, and we start looking how can we actually put all the Helm charts into single image and download and install them from it. And then I had a conversation last KubeCon with Stefan. He just said that we're trying to solve that wrong way, and there is already another solution which allows you to solve that. It's called FluxCD Source Watcher. That's actually new FluxCD controller, which allows you to compose and decompose artifacts the way you want to write in runtime. It's actually designed to work with OCI artifacts the way you want to. It's not tied only to Helm. You can use any FluxCD backend because all of these Flux controllers, they're replaceable and you can work with them the way you want to. In FluxCD, they have these two commands, so you can take some directory and just push it into OCI image, or you can download OCI image and extract. That works really fast, way more faster than you just building another Docker file, like just a seconds, and all your directory with Helm charts already in OCI, and you have a tag which you can use as single point of truth. In fact, it integrates with the same FluxCD entities. So the source controller is the first. You have kind Git repository, or you have kind OCI repository. You can even use kind Helm repository. Then you can create kind artifact generator. And out of this artifact generator, you got a few external artifacts generated. And then you can use standard FluxCD controllers like Helm controller, and you just specify that you have to install the Helm chart from the specific external artifact. That works pretty nice. Actually, with this new artifact generator API, you can build the charts you want to. You can pack dependencies right in runtime. You can construct the charts on the fly from the source code, from the different sources. The part chart can be stored in Git, another part in OCI, so you can do whatever you want. But the format is quite complex for the human. You can do mistake quite easily. So we decided, so this kind of low-level format, and we need to create an API on top of this. And also we got another business problem. At the time we were solving this problem, we got another one, that we got another client who wanted completely different platform stack, but still reuse some components. And that's the thing, how to make the things reusable. So for now we have few different type of clients. We have ISPs, enterprises, banks, and hosting companies. All of them need the same solution, but slightly different. They need the same things as others, but something new. And options are not enough for them. The bundles are not enough. They need the more better level of the customization. And we, in fact, want to build a product, not 50 different forks, which are difficult to maintain. That's the main goal of the business, that you do the same thing for multiple people and sell it for the same price. So in fact, we just want to have a single product, and we want to reuse the things. And at this time we just get an idea that we need a package manager, just like in any ordinary Linux distribution. Yeah, I got inspired by Alpine Linux because they got really simple interface of installing and removing packages. And we decided to repeat it, but in the Kubernetes level. Platform chart now includes not Helm releases, but package sources. Package source is a new CRD in our case, which actually results into artifact generator, which then results into external artifact. And when user wants to install, so they already have information, kget package source, they see all the packages available to install. And if they want to install something, they need to create kind package, which has the same name like package source. In our case, both APIs are cluster-wide. And package already creates a Helm release, which then use this external artifact. The logic looks like ordinary Linux distribution. When you connect apt sources, you do apt cache update, it downloads the source of all the packages to be installed, and then you run apt install and you install specific packages from the source you have already, the metadata you have in your local PC. So the package source looks like this. We have also a few differences to ordinary Linux distributions. Just because of the Kubernetes specific, we introduced variants. So every package can include variant. For example, our networking package includes options to install Cilium, Cilium with KubeOVN, or Cilium with Kilo. Every variant is actually just values files stored in the same package in our Git repository. And we have also a package which actually user intention to install specific package. In here, they have to specify specific variant, and they also have opportunity to override Helm values for all the components. Yeah, in our case, package can include multiple Helm releases. That might be really useful if you install, for example, cert manager CRDs and cert manager. But in fact, this is single package, and we still need to solve dependencies. And the package manager is the thing which actually solves the dependencies. In our case, we have two levels of dependencies. The packages can depend on different packages. That works even if you define packages from different repositories. But we also have this inside of the package dependencies between the components. For example, cert manager CRDs should be installed before the cert manager. These entities are solved by Cozystack operator, and it's quite dumb. It doesn't solve any dependencies. It just checks if a dependency installed or not. So we could compare it with dpkg, and we have user-facing tool which is called Cozypkg. With this tool, it's just wrapper around Kubernetes interface. You can run Cozypkg list. It will just show you all the lists of available packages with their variants. If you want to install something, you just specify Cozypkg add and specify the package name. It will solve all the dependencies chart and provide you options to install the dependencies in specific variant. And it can also generate fancy charts, like with those dependencies. That's the same like Alpine does with their package manager. So you can see all the dependencies of the packages between each other. And we actually found this scheme quite useful. That was working fine. But what to do with our existing clients? They already have chosen this all-in-one solution. And they have already Cozystack installed. They already using specific bundle with the components. And we don't want to break their experience because the simplicity is one of the idea of our platform. It might be quite complex to configure all of these open source components together, but we provide simple installation method, and we don't want to break it with opportunity to install all of these packages and explain to the users how it works. So we decided to still put some kind packages in our platform chart and install them when specific variant of this package have chosen. By default, we install nothing, just package sources, and let user to pick and choose specific the components they want to from the platform. But we also have predefined bundles, ISP full, generic, and hosted. So some specific bundles, predefined configuration and packages, which also includes migration scripts. So we just migrated our users to that bundles and continue working that way. In fact, we got these two options of using the platform. The first option is all-in-one distribution. It's like when you're installing Ubuntu desktop, you got a ton of the packages pre-installed. And the second option, build your own platform. It's like Debian net install, where you have minimal system, and then you just pick and install the specific components you want to. That's the thing. Let's talk a little bit about the evolution, because for now, Cozystack already includes many different packages. We got community contributions who continuously want to bring new functionality to Cozystack. And we don't want an error syndrome situation. If you know this software, there was software for building, for burning your CD-ROMs, but it started growing by continuously adding new functionality like video player, music player, and so on. So in fact, this project just get dead, and we don't get to get into this situation. Conclusion, we just checked what the other projects, how they solved that. And we found that they actually just decomposed the project to different zones of responsibility. And we invented pluggable repositories. That's the same idea, like every vendor can take a Git, they can prepare the same structure, prepare OCI image, and provide simple manifest to install it. In fact, the user of Cozystack, they can just take this manifest, install it in their cluster, and they will see the list of available packages. From my point of view, that should work very fine when we become even more popular. Some vendors will start preparing their own managed repositories for Cozystack. That looks like our or Ubuntu PPA. I think that will work better in a while. And the next steps is to decompose the components from in-tree and start developing them as out-of-tree repository. You can see all of these solutions, they started and they go the same way. First, they develop the components in tree. Like, remember, Kubernetes, they includes Azure, AWS bindings in the code from the beginning. Then they invented interface, like CSI, CNI, to let users provision external implementations and use it through this interface. And then they moved and they already deprecated all of these CSI, CNI drivers. They work only through those interfaces. In fact, we want to do the same in Cozystack. So Cozystack will remain just a framework for delivering such packages. And users, including us, like core maintainers of Cozystack, will provision our repositories. But in fact, you don't require to install our own packages because any Linux distribution or Kubernetes distribution, from my point of view, it's a package manager first. So you can use the same methodics to deliver your software or to make connectable repositories to Cozystack. So we can see that Kubernetes looks like a new Linux. It has the same developing path. And my idea that future is echo-driven Kubernetes distributions. So don't build platforms, build ecosystem. That's it. Few links I've mentioned in this presentation. Here is a link to instruction how this works, FluxCD source watcher, Cozystack, that's a tool which allows you to simply develop with FluxCD. It works even not with Cozystack. It just requires you Git repository at Helm. Example of how can you build this repository and publish it to the Cozystack. And finally, this article on Kubernetes.io, where I described how we actually build this API interface for representing Helm charts as normal Kubernetes kinds. Many thanks to my wife designer who designed this beautiful presentation. And that's it. Thank you.
Well done. Thank you so much, Andrei. Great stuff. We already have some questions coming in. You can submit your questions using Slido. So the first question is, how does your package manager deal with conflicts between packages, such as different versions of CRD in different packages, etc.?
For now, we just say that when you're developing repository, the core value of this repository to be sure that all the components in the same versions are tested and working fine. We have CI who is checking this, but we didn't solve the case when you have different packages in different repositories yet. That's a good question. I think we will solve that in a while.
Got it, got it. Yeah, me mark it as red. Yeah, I'm approving the messages going in here. Any questions from the audience meanwhile? Yeah, go ahead.
Thank you for the presentation. And I have a question regarding the version upgrades. Usually these components are evolving and new versions appear. And how do you resolve this version upgrades problem? How customers, users can upgrade their components to new versions when new versions appear?
We don't provide any option to install specific versions of the components. So every snapshot of our repository includes hard-coded versions. If you need to provide specific versions, you can provide them in values file. But in this case, you have commitment that if you provide this choice to the user, it will not break anything. So you need to have a test that matrix tests that they deploy some previous version or existing one, and you actually guarantee that it is working. And there is also another question about how we do the migrations. In our case, migrations are run a separate job of this platform chart. Before all the new Helm releases get installed, you have the opportunity to run shell script, which will do whatever you want. For example, remove CRDs or do some changes in the platform.
Thank you. Right. The next question is, when would I use FluxCD solution instead of Argo CD?
I have really big article about this. I really love two solutions. I like Argo CD and their interface. In case if you want to provide this interface to your developers, actually you can just let them use Argo CD, but not using having no access to Kubernetes. And they'll be happy just because they can see the state of every pod in development. So that works just fine. I still think that FluxCD is more Kubernetes-native. They have Kubernetes RBAC, and Flux is better for building distributions.
Got it. Thank you. The next question is from not Sam Altman. Any way to provide channels, latest beta LTS?
Yeah, that might be an option, and that could be really simply integrated. In fact, when you're installing the basic platform of from the Flux, you can pin to specific versions. So you can specify literally star for upgrading patch releases, but not upgrading the change releases. And we are thinking about reusing this strategy to enable automatic updates for the users of our platform.
All right, thank you. There's right now no more questions from Slido. One last question from the audience. We have space for one last question. All right. If not, thank once again, Andrei. Big applause for Andrei.
Thank you.